Today, we're looking at the production of our new pink collagen mask, made right here in our state-of-the-art clean room.
If we approach LAPCOS Collagen Sheet Mask from a purely hypothetical perspective, one fundamental question immediately arises. Where does the collagen in this product actually come from? For most consumers, collagen is associated with smooth textures, translucent liquids, and soothing skincare rituals. Rarely does anyone imagine its origin. Yet, according to one speculative scenario often discussed in the beauty industry, collagen used in sheet masks could begin its journey far from the vanity table, possibly with animal bones. In this hypothetical framework, animal bones such as those from cattle or fish are considered a plausible starting point. Scientifically speaking, bones are rich in collagen, a structural protein that provides strength and flexibility to connective tissues. This fact alone makes them a logical candidate when experts theorize about collagen sources for cosmetics. It is important to emphasize, however, that this remains a theoretical reconstruction, not a confirmed disclosure about the actual formulation of LAPCOS Collagen Sheet Mask. Under this assumption, the bones involved would not be arbitrary waste materials. In a carefully imagined scenario, they could originate from strictly controlled sources that meet safety and hygiene standards. Only bones free from contamination, chemical residues, or biological risks would be considered suitable. This speculative step already reveals something important. If collagen truly began here, quality control would have to start long before any laboratory processing ever took place. Once selected, these bones might undergo extensive cleaning procedures. Remaining tissue, fat, or marrow elements unnecessary for collagen extraction would theoretically be removed. The goal of this stage, within our hypothesis, would be to isolate the collagen-rich structure as purely as possible. At this point, the material would still look nothing like a skincare ingredient. It would remain rigid, opaque, and far removed from anything one would associate with gentle facial care. And yet, this contrast is precisely what makes the hypothesis intriguing. How could something so hard, so industrial in appearance, eventually transform into a substance designed to soothe, hydrate, and comfort human skin? This question lies at the heart of the speculative narrative surrounding LAPCOS Collagen Sheet Mask. If collagen can indeed be extracted and refined to the point where it becomes skin-compatible, then its origin may matter far less than the technology used to transform it. From a scientific standpoint, collagen derived from animal bones shares structural similarities with collagen found naturally in human skin. This similarity is often cited by experts as a reason animal-based collagen could be effective in cosmetic applications provided it is processed correctly. In our hypothetical scenario, this biological compatibility would be one of the key reasons bones are considered a viable starting material at all. Still, this raises a deeper question. Even if bones are rich in collagen, and even if science allows for their transformation, should such a source be used? And more importantly, how many steps would be required to ensure that the final ingredient is no longer recognizably animal in origin, but instead safe, neutral, and gentle enough for daily skincare use? At this stage of the hypothesis, nothing is certain. What we have is a possible beginning, a conceptual doorway into a complex process that may or may not reflect reality. But if this first assumption holds any truth, then the real story of LAPCOS Collagen Sheet Mask would not start in a cosmetics lab, but much earlier at the raw material level, where science, ethics, and innovation quietly intersect. And if this is only the beginning, what transformations would be necessary to carry collagen from rigid bone to a liquid essence soaked into a soft sheet mask? That question leads us directly into the next stage of this hypothetical journey. Continuing this hypothetical journey of LAPCOS Collagen Sheet Mask, the next logical question becomes not where collagen originates, but how it might be separated from its original structure. If we assume that collagen does begin within animal bones, then the challenge lies in releasing it without destroying its functional properties. In this speculative scenario, the extraction process would represent a critical turning point, the moment where raw material begins its transformation into a cosmetic ingredient. From a scientific perspective, Collagen within bones is tightly bound to minerals such as calcium and phosphorus. This structural rigidity gives bones their strength, but it also means collagen cannot simply be removed through mechanical means alone. Therefore, in our hypothetical reconstruction, the bones could first be broken down into smaller fragments. Crushing or grinding them would increase surface area, making subsequent treatments more effective. At this stage, the material would still be entirely unrecognizable as anything related to skincare. Following this physical breakdown, the fragments might be introduced into a controlled processing environment. Here, according to theoretical industry practices, mild acids or specialized biological enzymes could be used to dissolve mineral components while preserving the protein structure of collagen. This step would require precise regulation of temperature, acidity, and time. Even minor deviations could result in collagen denaturation, rendering it unsuitable for cosmetic use. In this hypothetical context, extraction would not be a rapid process. Instead, it might unfold over many hours or even days, allowing collagen molecules to slowly separate from the surrounding bone matrix. During this period, continuous monitoring would likely be essential. Samples could be taken at intervals to assess protein concentration, purity, and structural integrity. This imagined level of oversight underscores how delicate collagen actually is, despite originating from such a rigid source. The outcome of this extraction phase, if our assumption holds, would be a cloudy, liquid solution containing collagen in a relatively crude form. It would not yet be refined, stabilized, or optimized for skin contact. Instead, it would exist in a transitional state, no longer bone, but not yet a cosmetic-grade ingredient. This intermediate form is crucial in the speculative narrative because it highlights how much work still remains before collagen could ever touch human skin. What makes this stage particularly compelling is the inherent risk involved. If extraction conditions are too harsh, collagen chains could break down excessively. If too gentle, collagen might remain trapped within mineral residues. Thus, the hypothetical success of LAPCOS Collagen Sheet Mask would depend heavily on whether this balance could be achieved consistently and safely. At this point in the process, collagen may have been liberated, but it would still be unsuitable for direct cosmetic application. Its molecular size would remain large, and impurities could still be present. This raises an inevitable question. If extraction alone is not enough, what additional transformations would be required to make this collagen truly skin-friendly? And so, as this speculative extraction phase concludes, the collagen's journey is far from complete. The next step would not focus on separation, but on refinement, a stage where science would attempt to reshape collagen at the molecular level. What exactly would that involve, and how far could collagen be altered without losing its identity? That is where the next part of this hypothetical process begins. If the hypothetical extraction phase successfully liberates collagen from animal bones, the journey of LAPCOS Collagen Sheet Mask would still be only halfway complete. At this point in our speculative narrative, the collagen exists in a raw and fragile state. While it may now be separated from bone minerals, it would still remain structurally complex, with long molecular chains that are not easily compatible with human skin. This is where the next assumed transformation becomes critical: hydrolysis and refinement. In a theoretical production model, hydrolysis would be introduced as a method to modify collagen at the molecular level. Collagen molecules are naturally large, designed by biology to provide strength and resilience. However, skincare applications require a very different behavior. For collagen to function effectively in a sheet mask, it would likely need to be broken down into smaller units, often referred to as collagen peptides. These smaller fragments are widely believed to interact more gently with the skin's surface. Within this hypothetical framework, enzymes could play a central role. Carefully selected enzymes might be introduced to the collagen solution under strictly controlled conditions. Temperature, time, and enzyme concentration would all need to remain within precise ranges. Too much activity, and the collagen could degrade into meaningless fragments. Too little, and the molecules would remain too large to be useful. In this imagined scenario, hydrolysis becomes a delicate balancing act between transformation and preservation. As hydrolysis progresses, the collagen solution would gradually change. the once heavy protein structures would begin to fragment into lighter, more uniform peptides. Although invisible to the naked eye, this molecular shift would fundamentally redefine how the ingredient behaves. In theory, this is the moment when collagen transitions from an industrial protein into something capable of coexisting with the skin barrier. But hydrolysis alone would not be enough. According to our speculative model, refinement would follow closely behind. Even after enzymatic processing, the collagen solution could still contain unwanted residues, trace minerals, inactive enzymes, or byproducts from earlier stages. To address this, multiple filtration steps might be applied. Ultrafine membranes, centrifugation, or purification columns could be used to isolate only the most stable and consistent collagen peptides. This stage would likely be where collagen truly loses its original identity. No longer bone-derived in any recognizable sense, it would become a neutral, nearly invisible substance. Odorless, colorless, and uniform, the collagen at this point would be defined not by its origin, but by its behavior. In our hypothetical scenario, this is precisely what makes it suitable for inclusion in LAPCOS Collagen Sheet Mask. Yet even here, uncertainty remains. Refinement raises questions not just about purity, but about intent. How much alteration is too much? At what point does collagen cease to be collagen in a meaningful sense? These philosophical questions mirror the technical challenges faced in cosmetic science, where effectiveness and safety must coexist. If this stage were executed successfully, the collagen would emerge as a stabilized, cosmetic-grade ingredient. But stabilization does not automatically guarantee performance. The collagen may now be refined, but how would it function once applied to skin? Would it hydrate, support elasticity, or simply sit on the surface as a comforting layer? As this hypothetical phase concludes, collagen is no longer raw, nor is it final. It exists in a prepared state, waiting for context. The next question then is not about transformation, but integration. How would this refined collagen be incorporated into a sheet mask formula designed for real human use? That question leads directly into the next stage of this speculative process. Once collagen has hypothetically reached a refined and stabilized state, the question shifts from transformation to application. In this speculative reconstruction of LAPCOS Collagen Sheet Mask, the collagen is no longer the main challenge. Instead, the focus becomes how this ingredient might be integrated into a formulation that feels pleasant, functions reliably, and aligns with consumer expectations. This stage, while less dramatic than extraction or hydrolysis, could be just as decisive in determining the final experience. In a hypothetical formulation process, collagen peptides would likely not stand alone. Cosmetic science rarely relies on a single active ingredient. Instead, collagen could be blended into a broader essence composed of humectants, stabilizers, and supportive compounds. These additional components would serve multiple purposes: maintaining moisture, ensuring consistency, and protecting the collagen from degradation over time. In this imagined scenario, the formulation would need to strike a careful balance between effectiveness and comfort. The mixing process itself, according to this assumption, would be highly controlled. Collagen peptides might be introduced gradually into the liquid base to ensure uniform distribution. If added too quickly or under unstable conditions, clumping or separation could occur. Such inconsistencies, even if microscopic, might affect how the essence spreads across the skin. In a hypothetical production environment, precision would be essential. At the same time, the sheet mask material would come into focus. In this speculative narrative, the mask itself would not be a passive component. Materials such as plant-based fibers or biocellulose are often discussed in the industry because of their ability to hold liquid and conform to facial contours. In our assumed process, the sheet mask would function as a delivery system, ensuring that the collagen-infused essence remains in close contact with the skin for an extended period. The integration point would occur when the dry sheet mask meets the formulated essence. In theory, the mask would be submerged or infused until it reaches a precise saturation level. Too little essence, and the collagen would not distribute evenly. Too much, and the product might feel heavy or wasteful.